Resin Transfer Moulding, or RTM, is a closed mold composite manufacturing process. It involves placing a dry fiber preform in a closed mold, injecting resin under pressure, and then curing the part. Key advantages include a high surface finish on both sides, good dimensional accuracy, low VOC emissions, and consistent part quality. RTM is typically used for automotive body panels, aerospace interiors, wind turbine blades, and marine components. This illustration shows the key components of the RTM mold setup. We can see the upper mold, which is the moving half. The complex part geometry refers to the shape of the finished component, such as an automotive roof panel formed within the mold cavity. The dry fiber preform, or preformed reinforcement, is placed inside the mold before the resin is injected. A flow media or distribution layer is used to ensure the uniform flow of resin throughout the preform. The seal line or gasket ensures a leak-tight closure of the mold halves during the resin injection phase. Finally, the lower mold, or fixed half, supports the preform and contains the resin and vacuum ports. The resin delivery system includes a high-pressure pump that controls the resin injection pressure and flow rate. The vacuum system includes a vacuum pump and a trap. The vacuum pump creates a vacuum to remove air and volatiles from the mold cavity. Vacuum ports are utilized to draw out air and volatiles, ensuring complete impregnation of the fiber preform. The injection port is where the resin enters the mold under controlled pressure. The flow media helps distribute the resin evenly across the preform and reduces the risk of race tracking, which is uneven flow. Vent ports are used to remove trapped air or excess resin, ensuring the proper flow front advances and the part is fully molded. The first step of the process principle is to prepare the preform by placing the dry reinforcement in the lower mold. Next, the mold is closed and sealed tightly to prepare for resin injection. The third step is to apply a vacuum, evacuating the air from the cavity before resin injection begins. The fourth step is to inject the resin under pressure, allowing it to flow and impregnate the preform within the mold. Following injection, the fifth step is curing, where the resin hardens inside the mold under controlled temperature. Finally, in the sixth step, the mold is opened and the cured part is demolded and trimmed. RTM offers key benefits, including high fiber volume fraction and an excellent surface finish on both sides of the part. It also results in low emissions and waste and ensures good dimensional accuracy for the final part. The process is scalable for manufacturing complex structures with consistent quality. Now, let's explore the resin transfer molding process flow in detail. The RTM process begins with fiber preform preparation, where the dry fiber reinforcement is cut and shaped to fit the mold cavity. The prepared preform is then placed precisely within the lower half of the mold. Next, the mold is closed and the two halves are clamped together and sealed securely under pressure. The mold is then evacuated using a vacuum pump, removing all air and volatiles from the cavity. Once a vacuum is established, the resin is injected into the mold under high pressure. The resin flows through the preform, displacing the vacuum and thoroughly saturating the fibers. After the mold is completely filled, the resin is cured or hardened under controlled temperature and pressure conditions. The final steps are demolding and finishing, where the mold is opened and the cured part is removed and prepared for use. RTM is a versatile process utilized in several industries. In the automotive sector, it's ideal for producing body panels, structural components, and interior parts. For the aerospace industry, RTM is used to manufacture interior parts and non-structural components, where precision and consistent quality are critical. In the marine industry, RTM is excellent for producing boat hulls, decks, and structural parts that require durability and resistance to harsh environments. RTM is also employed in the wind energy sector for manufacturing turbine blades and other structural components that need high strength and stiffness. The process is also important in the construction industry for architectural cladding and infrastructure elements. This video provided an overview of resin transfer molding, including its principle, process flow, and applications. We reviewed the key advantages, such as high-quality surfaces, good dimensional accuracy, and low emissions. We also detailed the main steps of the RTM process, from preform preparation to demolding and finishing. Finally, we explored the diverse applications of RTM across the automotive, aerospace, marine, and wind energy industries. Thank you for watching this video on resin transfer molding. We hope you found this information valuable.